Welcome to the video lecture. In this video, we are going to solve a problem using student's t-test. It is a student's t-test is nothing but a statistical tool used for performing hypothesis testing. So I'll start off with what is a hypothesis testing. It is a testing used to compare population, that is evaluate the difference of the means for the two samples of data available. So the first step is to assume hypothesis. There are two types of varieties of hypothesis: null hypothesis and alternative hypothesis. So we have to assume the null hypothesis and alternative hypothesis here to perform hypothesis testing. It is represented as H0 and HA, and usually H0 is always considered as there is no difference between the samples of data, two samples of data, and HA can be assumed as there is a difference exists between the two samples of data. Let me explain you with an example. If you are having two drugs A and B and we have to identify whether these two drugs have the same effect on patients or having different effect on patients. So we have to assume hypothesis H0 and HA as we discussed that H0 is always assumed that there is no difference between the data taken. So drug A and drug B are having the same effect on patients is assumed as H0, and HA it is assumed that drug A is having different effect than drug B on patients. So this is a way of fixing your hypothesis, null hypothesis and alternative hypothesis to perform hypothesis testing. The solution can be achieved by either accepting the null hypothesis or by rejecting the null hypothesis. So this is the difference of mean we have talked about. H0 and HA are assumed here, and mu1 and mu2 represents the mean value of two different population. So this is the hypothesis testing can be graphically represented here. X1 is X1 is one data sample and X2 is another data sample. So this is a distribution of X1 and this is a distribution of X2. So whether we are going to find whether these two samples belong to the same population or different population. That is, if they are having same mean, then it belongs to same population. If they are having different means, then they belong to different population. So if this shaded portion is the overlapping area is large, then it is approximately equal. X1 is approximately equal to X2. If there is no overlap between X1 and X2, then it is not equal to X2. So here in this video we are going to find the difference in means using student's t-test, and student's t-test can be used for the problems if for the distribution of two populations have equal means but unknown variances. So if the variance of the given population is unknown, then we can use student's t-test to perform the hypothesis testing. So the formula for performing student's t-test are given here. So T is a T distribution, and X1 bar and X2 bar are the mean value of the respective samples 1 and sample 2, and SP is the variance of the total population, and N1 and N2 are the number of variables present in the samples 1 and 2. So here the total population variance can be we have to calculate the unknown variance. So the total population variance can be calculated from the given values. So here S1 square and S2 square represents the variance of sample 1 and sample 2. This N1 plus N2 minus 2 is termed as degree of freedom. So for the problem is given here. The nicotine content in milligram of two samples of tobacco were found to be as follows: the sample 1 and sample 2. So we have to check whether these two samples were from normal population with same mean or not. So here they have provided you a table value of alpha at 5% level. We will discuss about this table value later on in this video. So from the given value, we can calculate the N1 and N2. N1 is nothing but number of samples present in sample 1, and N2 is the number of data present in sample 2. So N1 is equal to 5 and N2 is equal to 6. And To calculate the total population variance, we have to find S1 square and S2 square. The formula to find S1 and S2 square is given here. So to calculate the values, the formula is given here, and then we have to find, the first step is to find the mean value for the given data. So the mean value can be calculated from summation of values of x1 divided by total number of values of x1, and x2 mean value can be calculated from summation of total values of x2 divided by total number of samples present in x2. So the x1 and the x2 bar has been calculated from the given data, and so the sample 1 is considered as x1 and sample 2 is considered as x2. So this is the data already given in your problem. We have to find x1 minus x1 bar whole square and x2 minus x2 bar whole square to find the values of s1 square and s2 square. So after the values are calculated from the given data, so by applying the values of x1 bar, perform the function and calculate the given values, and these are the values we have calculated for s1 square. Apply the values in the formula of s1 square and s2 square. So you will obtain the values, obtain these values. So after finding s1 square and s2 square, just substitute the values in sp square. So in this formula to calculate the s square. So that is variance of total population. So the variance of total population, the value of the variance of total population is 11.88. So after calculating the variance, we have to do the hypothesis testing. So the first step is assuming the null and alternative hypothesis. So the null hypothesis H0 is mu1 is equal to mu2, and the alternative hypothesis, that is the difference between the means of the two populations. So the next step is finding the level of significance. The level of significance is the degree of freedom. Finding the degree of freedom, which is already mentioned as n1 plus n2 minus 2. The degree of freedom is represented using this symbol. So n1 plus n2 minus 2 is 5 plus 6 minus 2, which is 9. Here the table value of alpha at 5% level is given here in your problem itself. I will tell you how to calculate the table value. So it will be provided a statistical table value. So this is already been fixed for some values of t distribution for some alpha value. So for here the alpha value is considered as 5%. So for 5% of alpha, the t distribution for the given degree of freedom. So the given degree of freedom is 9. So for the given degree of freedom for 5% of alpha, the t distribution value is 1.833. So this is how your table value should be calculated. So here it is already mentioned in your problem. So this is the table value of alpha at 5% level, and we have to calculate our own t distribution value from the given data by applying the values in this formula. So you will come into a conclusion of t value as minus 2.108 by applying the calculated values in the formula. Now the next step is we have to compare calculated value versus table value, whether the calculated value is less than the table value. So your calculated value is minus 2.108 and it is less than 1.833. So the condition satisfies. So if the condition satisfies, we have to accept the null hypothesis, which is H0. So hence H0 is accepted. Thus we can conclude that both the samples are from the normal population with same mean. So this is how your hypothesis testing can be performed. And here in this video, we have performed hypothesis testing using student's t-test. There are various other techniques available to perform hypothesis testing. So here we have discussed only about student's t-test. Thank you for watching the video.